Okay, these, remember, be very careful about what your domain and range are. What's allowed to go in, what's allowed to come out. If you remember those things, this is just look it up on the circle. Please write the stages of it like we were doing yesterday. Like, handle the inside function, then the outside function. Show the steps.
Oh.
That way I can give you credit if you have a goof. Okay?
What do you mean handle it inside? Oh, like say with the cosine of that?
Do it in stages. Just like I would prefer you did that on a quiz so that I can give you partial credit if you have a goof. That I hate taking full points off when someone, I know what they did. I know they just missed this one thing, but they don't have anything to back it up.
It's undefined. Can it still get that?
You tell me.
I don't know.
This part we specifically went through yesterday. That's why it's up there. We'll go find a similar example. Everything here is open notes, open everything. Y'all, I'm a tired Papa Bear. There's a very good chance that these are one of the examples we did yesterday, and I just am not very original. Okay? Anyone need more? Okay. I'm never sure if you're like still writing on this or if you're just doodling or whatnot. Okay. What's the domain of cosine?
0 to 5.
Regular cosine.
Oh.
0.
All real numbers.
Oh, cosine.
No, regular cosine. I'm starting inside the parentheses. Regular cosine. I can take the cosine of any angle, right? Where's 5 pi over 2 on my unit circle? Okay, it's not. I got to go around, find the coterminal angle of pi over 2. Okay, then, what's the cosine of pi over 2? 0. So I do this in stages so I can get that partial credit in case I goof. I'm going to say the arc cosine of, now the range of cosine is negative 1 to 1. Okay, now it's arc cosine. What's the domain of arc cosine? Now that's negative 1 to 1. So I got to check that it's a legal target. It is. Then I look in what 2 quadrants am I allowed to go to? All right, so we're looking from 0 to pi. Where do I have a cosine value of 0? Right, I can't say 5 pi over 2 because it's not in my range. I have to say pi over 2, which is closer. Okay? Tangent of negative 5 pi over 2. A normal tangent doesn't have all real numbers. It has infinite number of asymptotes at different period intervals. Okay? So I got to be careful when I'm doing this. What is the tangent of a negative 5 pi over 2? So I got to go around, then down again. So I'm down at negative pi over 2 or negative 90 or 270, wherever your coterminal angle is you want to call it. And it's undefined. So now I have the arctangent of no. And this was the thing that we specifically talked about yesterday. I can look on my unit circle and I see where tangent is undefined. It's at plus or minus pi over 2. So can I say plus or minus pi over 2 for my answer? No. Because you show me the undefined button. You show me in all real numbers where undefined is. It's not a legal input. It's not part of my domain. Additionally, the range is from negative pi over 2 to pi over 2 with parentheses. It's got asymptotes there. I can't say that as my answer because they're not included. So the answer is just no. The next one. I got to draw a little triangle. So it's arc cosine. Is arc cosine restricted for domain? Negative 1 to 1. Is that a legal target? Cool. So I know I can do it. Where am I looking for my answers? 1 and 2. Which of those 2 quadrants is going to have negative values? All right. So I'm going to draw a triangle in quadrant 2 with a cosine of negative 4/5. I'm going to get some angle. Now go find the sine of that angle. I need to find the opposite side. Good thing I know what my ratios are, right? So now when I go find the sine of this angle, it's just 3/5. So, I'm going to say, for the stages, did you have your triangle and your answer? Did you have your initial and your answer? And I'm going to say 1 for this. because you could have just said, oh, well, remember this, no means no. Okay? You could have just gone straight to, nah, that ain't possible. Okay? Any questions about it? The homework, I threw one of the arc reciprocal functions on there. And this is what sleep deprivation does to us. I said part of what you need. Remember that tangent has asymptotes at negative pi over 2 and pi over 2, and its graph goes like this, right? So when I do arc tangent, I'm restricted into negative pi over 2 to pi over 2, quadrants 1 and 4. I had told you yesterday that arc cotangent is just 1 over arc tangent. And that is true. But we have to remember where cotangent exists. Because cotangent, if you remember from video day, has asymptotes at 0 and pi. And goes down like this. So yes, you are just doing the reciprocal of tangent, but you ain't looking in quadrants 1 and 4, you're looking in quadrants 1 and 2. And I just plain missed that part yesterday because I was tired. So sorry about that. That is something you got to keep in mind for this. With arc cosecant and arc secant, same business. No big deal. Okay? But that happened to be the one that I put on the assignment, and I goofed that, so. Whoopsie. We do okay with the rest of them? We do okay with the, there was one that had Pythagorean triple values in it, but it's just find the two angles, subtract the angles, dump it in a calculator. I hope we're okay with that. So, we left off with law of sines. We did the top one, right? I don't remember if we finished it. Okay. I want to show you a shortcut before we get started. The triangle, or that there's a shortcut? Okay. First up, if you can find a missing angle by just subtracting from 180, we always do that. So this was 103 minus... Okay. The core behind this was to find my control pair. My control pair is going to be whatever angle and side is across from it. And I would start with that in the middle. And we'd say the sine of 103 over 20 is, we go find our other guys. That guy and, nope, that guy. Okay, it's always the side with the angle across from it. And when I set these up, we had now sine of 42 over little c and sine of 35 over little a. Before I started anything, do I know which one's going to be biggest and smallest?
If you know the degrees, yes.
Yes, because we have that triangle proportionality thing. And then we did the alpha Jesus goldfish thing, where we'd say multiply the two that line up, divide by the one that doesn't. So C was 20 sine of 103, and then the sine of 42 went here. Nope. And then over here, if I multiply the two that line up and divide by the one that doesn't, we'll get A is 20 sine of 103, and the sine of 35 goes up top. I write them like this with the colors like this because there's a shortcut here. Do you see how my control pair was always there in my solution? So I would like you to write on here, we get a little cheater shortcut that says if I'm looking for side A, I'm going to take B sine of A over sine of B, where this is my control pair. Okay? Now, what A and B are doesn't really matter. That's arbitrary, right? We can name the angles and vertices whatever we want. But my control pair is always going to be in those spots when I'm solving for a side. Now you notice at the top it says solving law of sines for angle, angle, side. Today we start talking about the other ones. Yeah, that's right. Y'all remember back in geometry, right? There's no ass in geometry, is usually what most teachers say, something like that. You can't do angle, side, side because of what we're going to talk about today. Okay, so if you have that little cheater shortcut, from here on out, I'm not going to write out the full proportion cross multiply and solve. I'm just going to write that because I know it ends up like that every time. Okay? Go ahead. Solve for some missing stuff. Find the missing angle and the two missing sides. Make sure you write the expression answer and the decimal approximation, both. Okay, we got to know this. We got to know it well before we can start talking about the weird cases. That's why I always identify my control pair first.
How do you know?
It's your angle with the side across from it that you're given. Just like in a scientific experiment, your control is the thing you didn't mess with.
Then you say 13 equals.
Those two are across from each other. Those two are across from each other.
Oh, 13.
These two are across from each other. These two are across from each other.
What's the sign of S though? What's the control pair you use for B? I don't use this.
So that's 110, 114, 66, order 66.
What's the sign for
S is going to be, put your control pair on there, side then angle.
Yeah, I got that. But
So it'll be 13 here, sine of 63 here. I'm trying to find little s, so across from it is sine of 51.
why did you use T?
Because I'm finding s.
When you plug it in your calculator, you have to.
Yeah.
Well, I'm saying, why did you use the R value?
Because that was my control pair.
But technically T. So how do you find big S?
I don't know the value of t yet. I don't have a control pair here. I know angle t now, but I don't have the side across from it. So I can't use that to find the others.
You don't have to find big S. T equals.
I already have it.
So you just have to find little s.
Mm-hmm. And then little t. Use your control pair. 13 sine of 63. Since I'm finding little t, I put big T here. Okay. Now again, this is just a shortcut. You don't have to use the shortcut. Some kids get confused by the shortcut. If the shortcut was the more optimal way to do it, it would just be called the way. Right? Shortcuts have to involve a little bit of maneuvering. In this case, some mental gymnastics. That belongs to the leeches, and they're supposed to come back for it. They insist on calling themselves the Tres Leches.
Oh.
Because why not in Western South Dakota have three privileged white boys call themselves the Three Milks? God, those three. Yeah, they did a lot of dumb, so they owed us food. They brought in food. I don't know why they left it there. You'd think they would walk away with it. But, for the other one, same business. Okay, if I want to find little L, I'm going to do little L is, my control pair is 18 and sine 29. It's paired with 25. If I'm trying to find K, I better go find angle K first. The measure of angle K is 180 minus 29 plus 25 is 54, so 131.26. So, little k, start with your control pair, 18, sine 29. Now I know the angle to pair with it, so sine of 126. Let's make sure that we're all pressing the right buttons and in the right mode. S. What we got? You do have to be in degrees. So what? Okay. T. L. No, do it. No. How votes the village?
16,691. 691.
Okay.
Just try it, Max. 69 on this. No.
Okay. Okay.
Oh,
16 point who what? I was, but then after I said it, I realized that's a really good segue. So, this is all about monkey button pushing. The one that comes right after this is just word problem context. I'm sure we're going to be fine with it because they already drew the pictures out for us. I see squinting. I see the furrowed eyebrows. Is something goofy? I'm trusting all of you to... All right, well, little l is across from 25. K is across from big K. It should be a lot bigger than that, right? In fact, it has to be bigger than 18 because it's the biggest angle.
what? I got.
Guys, don't worry,
I put in sine 26, not 126. Don't worry, guys.
Okay. All right, 30 and change. Okay, so that's the part I wanted to say is as you're doing these, you can check for reasonableness of answer because they should match with proportions. If 18 goes with angle 29, then something way bigger than 18 better go with something way bigger than 29, right? Like they should match by proportion. The word problems for these are mostly just blah, blah, blah. Can you draw it out and then do the same thing? The irony that they're talking about satellites and Langley, just great. None of you know what Langley is, do you? Anyone? Emrys, save me. No? Langley is the headquarters of the CIA. So, right? So, Virginia, it says it right there in the problem. So, if they say that the angle of elevation from the lab to the satellite is this, from the research center, going through all your private data, is from Langley up to the satellite is 72, and those two towns are 446 miles apart, go find blah, 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 solve the triangle. You can do that, right?
Yeah.
What's missing for us to start? Because I don't have a control
You gotta
pair.
get a side, which you just do like the sine.
I got a side,
Oh, you did? Never mind, then you're good to go.
but I don't have a control pair.
Well, yeah, you do.
No.
Yeah, you do 50 and 46.
58 is not across from 446. Where'd you get 50 from?
I did the thing.
Oh, we had to do some math to get our control pair. Okay. So we'd have to say, oh wait, that doesn't show up at all. Okay. Here we go. I would have to say the measure of angle C is 180 minus 58 plus 72, which is 120, 130, okay, 50 degrees. And now, Mr. Shortcut, now we have a control pair. And you'd be good to go, right? So I'm not worried about this page at all because they're already drawn for us. I'm concerned that you can draw it. Okay? So we'll just pull something out of an orifice and see if you can draw it. So up here, I'm just going to say, yeah, I get it. But then we're going to cross this out and I'm going to write my own. I want you to be able to draw something from word context. Okay? What did we use last hour?
Two shifts.
Oh, okay. It was
What though?
Oh, I knew he was gonna do that with it.
There. Can you go from context? Purely because I saw someone playing one of those stick figure shooter games this morning. Then use the space above it, since we crossed that out. No, it's not. In fact, it's almost identical problem. Uh-huh.
Bro, if the triangle, it has an angle.
You work together. This isn't a test.
Same, going to the same place, angle of,
Well, I don't understand.
depression.
Further away.
Okay, literally.
Who says that the target is exactly halfway between them?
This.
All it matters is that it's an angle.
Yeah, you could say that, but then you wouldn't actually understand.
I understand.
You just like see the two numbers going.
Okay, when I say argue about it, I don't mean like get heated.
I don't understand. Angle of depression is this, right?
They're on top of a building.
Yep. 400 feet apart. And they're looking down.
They look down.
Guess you could draw it like.
Uh-huh.
But the angle of depression isn't right here.
Yeah, it is.
What? How? Then we have to be straight ahead. But it's a triangle.
400, sniper A. B.
Yeah, I know. But it's a triangle. So that would have to be like
How far does each bullet travel?
this.
Mm-hmm.
And then the triangle is over. But the target.
He looks down that far. He looks down that far.
52.
You're breaking my brain because that right there doesn't make sense because it's straight ahead. The angle of depression, he's looking down straight ahead. Where in this problem, they would have to be looking to the side and down. Can they do that?
How about this? Sniper A looks down like this.
So
Right.
they're looking at an angle down.
Uh-huh. And Sniper B is also looking down.
Okay.
It's just that these two are touching because they're looking at the same thing. They're just not exactly the same distance to the target.
Okay, so the buildings aren't next to each other and the target's over here. It's really the buildings are right here and the target's right here.
Yes.
Oh.
So, this is the right.
Looks about right.
It's all the degrees are right too.
I mean, the setup is right. I don't know about the values.
Target's in the middle.
Mm-hmm.
Okay, that's where I am.
So I'd have a building, we'd have sniper A up here, B up here, we'd have our target down here, and they're both looking down at him. That just doesn't mean that they're exactly the same distance from him. But we know that they are 400 feet apart. We know that this guy's looking down at 41 degrees and this guy's looking down at 37 degrees. I want to know how far this traveled and how far this traveled. Okay. And those angles are pretty close together, so I bet your sides are going to be pretty close together. Like, what was it, 400, 3690, 5, 5, 2 by 2, so 2 of that, 200, but then plus change, so what, like 240 and 280 or something? Or 250 and 300?
Is this
268 something? And 246?
240?
What?
How you set it up?
I don't know how to set it up. Makes no sense. So then would you do sine of 30?
So you'd
41?
have 400
Yep. Sine
over sine of 92.
Yep.
If you're trying to find this guy,
41.
sine of 41.
Sine of 41.
Yep. So this guy is going to be, well, first of all, you got to find your angle. I suppose we should do that. 437, 78, so 92. There we go. So now you have a control pair. You're good to go. I'm going to have a 400 over sine of 92. I'm going to have a 400 over sine of 92. What? 70? Crud. Well, got him. 102, 102. And then, if I'm trying to find this one, I'll use the angle across from it, sine of 37. If I'm trying to find little a, I'm going to have sine of 41. Okay, which means you said it was 260 something, 240 something? Yes? Okay. All right, just making sure that you could draw your own. I'm getting there. You got time. You have to get to 15. Or 17. I told my wife, as we're getting sleep deprived here for 6 months straight, said those extra points can come in like 2-3 days. So, who here does like wood shop, welding, anything like that? Okay. You remember the whole angle side business, right? Nom. There we go. This is triangle, correct? The base in between them is, okay? So if I know that this length is always going to be the same, dinosaur is not magically going to grow. If I know that meter stick is always going to be the same, not magically going to grow. What if I were to weld this angle in place? Okay? But this one isn't locked in place, right? Angle, side, side. Can't I still make a triangle like this?
Yeah.
So this can hinge back and forth, making two different triangles. Even worse, what if the angle was locked in that place? It doesn't make a triangle at all. Right? Like it can't reach.
Oh, this is the side right here.
Uh-huh. So that's why if this angle is locked in place, you have this weird possibility that this could have been an angle. That's an acute angle down there. Or this could have been the angle. That's an obtuse angle. And that specifically has to do with sine and arc sine. Where is arc sine restricted? Negative pi over 2 to pi over 2, right? So if this is arc sine, then I can use the law of sines to also find angles, right? If I'm missing an angle, I'll just use the arc function of the ratio and I'll be able to get my angle. The problem is, can you have, for example, a 135-degree angle in a triangle?
Yes.
So if I do arc sine, uh-oh, right? It starts getting weird. Like, what about this? How about let's use a nice one instead. This is 1 and 2. This is 150 degrees. If I did the arc sine of 1/2, what's it going to tell me? It ain't going to say 150 because I'm not allowed to get angles in that quadrant. It's only going to give me 30. So how do I handle it when it was supposed to say 150, but it told me 30 instead? Would I even know that that's a possibility? Well, you're in radians.
No, I'm in degrees.
You did not do the arc sine of 1/2 and get domain error.
Oh, I did it at 150.
Because
You can't.
arc sine has a domain of what?
Pi over 2.
No.
God damn.
Oh,
That's the range. What's the domain of this? You're only allowed to bounce between -1 and 1 on a unit circle. You just asked, where do I have a sine value of 150? That's like the 39th ring of that that circle. Okay, that don't work.
Do you have any batteries for graphing?
No.
Can I borrow a graphing calculator?
Till when?
Till like the end of this period?
Yeah, go for it. No, batteries would mean Robbie had like me. So we have to deal with this possibility that when we're doing arc sine, because it's only going to give me acute angles, but there's possibly obtuse angles and triangles, I have to take into account certain things. I need to charge them, yes. So when we have angle, side, side, there's two possibilities with the angle that we're given. Either the angle itself is obtuse. If they give you an angle that's obtuse, and then I do arc sine to solve the problem, will I ever get another obtuse angle?
No.
No! You can only have one. So that means there's only one triangle possible. Because I was already given an obtuse angle, that means there's only one possible answer for arcsine. However, if it's an acute angle, okay, as Mr. Devon Larson told me in 1999, if it's a big ass, you know what you're getting into. If it's a cute ass, you in trouble. Because now there's one triangle possible if it's a right angle. There's two triangles possible if I get an acute angle. Or there's no triangles possible if it tells me error. Okay? I'm going to try to solve a triangle by law of sines, given angle side side. And it might get weird. Okay? That is what the ambiguous case is. Why you got to be taking pictures of my... So... All right. That's what this whole page is about. They're showing this side being able to hinge back and forth, where it could have went straight down and made a 90-degree triangle. It could have hinged either of these directions if, depending on the angle up there, I could have had an obtuse angle or an acute angle, or it could have just been too short and never made a triangle. There's conditions to help us determine that, but they're overkill. You notice even the books, they just refuse to put it. So, they're going to give you some measurements, and you will draw your triangle and start trying to solve it by law of sines. So, I have a 94-degree angle, so I'll draw a 94-degree angle. You know, a little more than 90. And I'll put A there, 94 there. Okay. Where does little a go?
Right here.
Across from it. And you can put little c wherever you want. Because we've been hinging this top side, I like to put both of my side lengths up here and just make this go slide back and forth. So if little c12 is here, what else do I know? Big C's down here. So that means big B's up here and little b down there. So look at the information that I was given. I was given angle, side, side. What kind of angle was I given? I was given an obtuse angle. So I'm okay. I'm either going to get no triangle possible or I'm just going to get one triangle. Okay? Most of the time I just get one triangle. So, do I have a control pair to get started? Yeah, I do. Okay, I got this as my control pair. What should I try to find first, angle C or angle B? Because I don't have a side across from B to compare it to. So, we're going to come over here and say that the sine of 94 over 15 is the sine of C over 12. Cross multiply solve. Oh, the trick doesn't work now because I'm not finding side anymore. Multiply the two that line up. Divide by the one that doesn't. We have 12 sine of 94 over 15. Plug it in. Make sure you're in degrees. What do you get?
I'm getting it. Didn't you file? Thank you.
Yeah.
So you would do.
Okay, so y'all got the like furrowed eyebrows of what the? Because I'm getting an angle of like less than 1 degree. Look at what it equals. The sine of C. And the sine of C should be between -1 and 1. How do I find the angle? Arc functions. Okay, I undo sine with arc sine. If I want to know what angle C itself is, I need to do arc sine of that. That'll get me the angle. A little bit better? Okay. And that's why we have to talk about that ambiguous case. Because in order to solve these, I need to use arc sine. And arc sine only works in quadrants 1 and 4. Well, I can't have a triangle with negative angles in it. That's dumb. So I need to go up into quadrant 1, which means only acute angles. 52 point who what? Cool. Hey, I can find B now. And this is how I'm going to write it, and this is why I want you to know where that answer button is on any calculator you may use. The measure of angle B, I'm going to write that as 180 minus 94 plus my answer. I'm actually going to use the answer button. Because then, yes, I made the 3 decimal point rule for my classes by literally these. Like, this is where kids fell off in geometry. They were having trouble moving these expressions around. So I told them to use decimals to 3 places. If you use the decimal to 3 places, by the end of the problem, your answer will be just a hair off because of round-off error. But if I shove answer in there, it's taking this entire calculation that's in your calculator and shoving it in. 33 point who where? 056? Okay. And now that that's my most recent answer, okay, now Jace, I'm trying to find a side. Now I can use the cheater. Okay. Now we can use the cheater and say B is control pair, 15 sine of 94. But because that angle is now in the memory of my calculator, I'm going to say sine of answer. Because then it's going to dump it in for me. And really, if you go to 3 decimal places, your final answer here, you're talking about being only a couple thousandths off of your neighbor. Like, that's where this rule came from. And what do we get? No problem. 8202? 8.202. Okay. I was going to say 80 is a little chunky for this triangle. Okay. Now, we do have enough time for the other example because it goes very fast. Set up the triangle again. Put 61 degrees in there. Angle A, little a, and I like to put my side lengths up at top. So I'll put little b of 11 here, which means angle B here, which means C here, C here. Do I have a control pair to get started?
Yes.
Yeah, I do. And I'm going to go find angle B. But before I do, I want you to look at what kind of angle side was I given. It's a cute one. I'm in trouble. Because I might have no triangle, 1 triangle, or 2 triangles. So I'm going to set this up as the arc sine of, I'm still going to have the control business going on there. It's just they're going to flip-flop. Sine of 61 here, 9 here, and my 11 will go here. Again, you can set up sine of 61 over 9, sine of b over 11, cross multiply solve. You can do all that. And what happens when I dump it into my calculator?
Not triangle.
Uh-huh. So I will just say, next to this, my answer is no triangle. Okay? Alright, so we'll pick up with this tomorrow, and you're going to get the weird ones where we get 2 triangles. Okay? And I know that there isn't a video for that, because last semester Frank died and I had to take up the entire whiteboard to do it. So, let's hope that nothing catastrophic happens in the next 24 hours, and I'll actually be here.